So again, don't give me a P here. It has to be rho. You cannot give me something like that. No P's. It's got to be a rho, or you spell it out rho. Okay, great. Continue.
Alpha is equal to 0.01. Number 3, Lindreg p-test, L1, L2, frequency 1.
Yeah, what did you get for your p-value? It looks like it's 0.3.
0.3876.
76. What did you get for your R?
I got
307, I think it was. People got.
307, yeah.
Yep. And then what did you get for your A and your B?
I got negative 3.506, or negative 3.507.
Wait, I'm sorry, A is negative 3.507.
07.
And B was
0.4458.
58. Okay. Good, good. Did you get a Y bar and an X bar? Did anybody get an X bar and a Y bar?
Yeah.
What did you get?
60.1 for X bar.
60.1 and Y bar?
23.29.
23.29. Okay, good, good. All right, great. Connor, continue.
Because p-value is bigger than alpha, did not reject H naught, so that means there was not enough evidence for a linear correlation between age and network.
Age and network. You got to write that in, or you lose a point, right? It's worth writing it down just to get that extra point on the exam. All right, everybody all on board with this? Good, good. So what we're looking at here with the R's is what we're testing is H naught again says that you're right here in the middle, right? No correlation. If you get something in here like what we got, then okay, yeah, there might be no correlation. If I get something way out here towards +1 or way out here towards -1, then that's when we say that it is aligned. It's close enough to being 1 or -1 to be aligned. How close? To find that, we'd have to use a PPMC table and look it up. And I don't want to give you folks yet another table and go that route. Instead, we're going to stick with p-values. So the idea being that if your p-value is less than or equal to alpha, that means that you are close enough to +1 or -1 to be aligned. And if your p-value is larger than alpha, then that means that you are not close enough. Okay, so there are, if you do find correlation, there are several possible reasons for that. Brittany, go ahead and read.
When the null hypothesis has been rejected for a specific value, any of the following 5 possibilities can exist. There's a direct cause and effect relationship between the variables, that is, x causes y. There's a reverse cause and effect relationship between the variables, that is, x causes
Y causes
x. The relationship between the variables may be caused by a third variable. There may be a complexity of interrelationships among many variables. The relationship may be coincidental.
Exactly. So when you find that there's a correlation, it could be x causes y, y causes x, a third variable is causing both of them, or is a whole big mix of stuff going on causing stuff to go on, or it could just be a coincidence. Right? So that's always a possibility. That could happen. Randomly, 5% of the time. Okay, so does everyone feel good, solid with our hypothesis tests? Perfect. Now we're going to move on to the second half of chapter 10, which is regression. The regression line, it's also known as the line of least squares, is the line that best fits our data. So kind of find a line. If you have the line that best fits your data, how do we do that? I actually had to do this long, long ago. I was in school. You compute the distance straight up or down from every point to that line. Find all those distances from the point to that line straight up and down on in the y direction, and then you square all those differences, and you sum them up. You add them up. So that's why it's called the sum of the least squares. The line that has the smallest sum of all the squares of the distances, that is your linear regression line. a little bit cumbersome to find. There's a big long formula for it. It is, where is it? Why can I not? Okay, it's right here. However, we're just going to use the TI calculator and the linear regression t-test to find A and B. It's a lot simpler, a lot more straightforward. I know it's what everybody does nowadays. I had to use the formula, which was certainly better than manually trying to compute them all the differences. I'm actually really thrilled to get the formula, because at least that was a lot easier than trying to like, they made us find all the different distances up and down to the line and square them all and add them all up, and that was a big pain. So this is certainly better than that. But even better are you folks having super cool TI calculators, which you know, they didn't have anything nearly as good as these in my day. I know that these TI-83s seem really old, and they are really old, like 25 years old maybe, but I'm way older than that, so we didn't have those. All right. Then the linear regression line itself is y equals a plus bx. X is the explanatory variable, the independent variable, right, the one you can mess with, and then y would be your dependent variable. Yeah?
Isn't this basically y equals mx plus...
Y equals mx plus b. Right, only it's y equals bx plus a, and we just flip them the order they come in. Yeah? Yes?
Why is the apostrophe there?
It's y prime, so just indicating that that's a prediction for y. Yeah, it's, I usually ignore it, honestly, but you know, it's technically there. This line, we use it to predict values of y for a given x, or vice versa, only when my data represents a line. So in other words, if I reject h naught, I have a small p-value. If I reject h naught, then it is a line, and you can use a line to predict. If my data is not a line, in other words, my data is random, I did not reject h naught, then you should not use a line to predict. And I'll show you what we're talking about here. For example, shoe size and exam scores. I can make a line for this. Like that there. You can find a line for any data, right? That's the line that's least squares. But who thinks that shoe size and exam scores are related? They are not, right? And you can see that there's a relationship here. But there will be a line that will occur for it. So we give an exam. The lowest score is, where'd my pen go? Here it is. My lowest score, the minimum, is 50. The max was 100. The average was 80. What is my best guess? Someone comes in and says, Ms. Young, I'm going to take your exam now. I have a shoe size of 4. What's my best guess at what grade they're going to get on their exam?
You don't know?
Well, what's your best guess?
80, is this the average?
The average, exactly. Does that make sense for folks?
Yeah, that's the best point estimate.
That's the best. Yeah, that's the best point estimate. That's the best guess. That's so. The average would be your best guess. Does that make sense? So if I'm trying to guess what their exam score would be, my best guess is the average.
Yes.
So my best guess for y is y bar. Y bar is the average y. If I wanted, if I looked up and said, let me grab somebody randomly from the whole population, I grabbed somebody and they scored 100. What's my best guess at their shoe size? The average. The average shoe size. Does that make sense?
Yeah.
So for men that might be size 8, for women it might be size 7, something like that. Is that everybody kind of following? So if you don't know what x or y is, if you're trying to guess what x or y is, if it's a line, if there's a correlation, you can use the line. If there is not a correlation, if you did not reject h naught, then there are a bunch of random dots like this. Your best guess at x is x bar, the average x. Your best guess at y is y bar, the average y. Everybody feeling okay with this? Okay. So we're gonna have you folks write some of this down. So this is the middle of page 77, maybe? 78. Okay, so using the regression equation, only use it if there is a linear correlation between the two variables. So in other words, if you reject H naught, if I reject H naught, my p-value is what? Small or large? Small. Small p-value. Then it is a line. It's a line. So, it is a line. So then you would use y equals a plus bx, which Raphael pointed out is very much like the standard, like y equals mx plus b. It's y equals your slope times x plus your other number. Okay, everybody have this down? This is pointing out the fact that you have to be careful about how far away you can predict. So for example, cell phone usage. I have data for the last 40 years on how many people use cell phones. Think it's reasonable to predict how many people are going to be using cell phones in 100 years? 100 years from now? No, they might not. They probably won't be using cell phones 100 years from now. They'll have something like implanted in their brain or something. I don't know exactly, right? But we can't predict that far in advance. For the last 40 years, I might be able to predict maybe 10 years, maybe 20, maybe. But based upon this amount of data, I should be able to go, infinitely far into the future. So that's the first caveat. The second one is if your data is not correlated, like shoe size and test score, then you can't use the line to predict. If your data is not a line, don't use a line. Instead, use the sample mean. So in other words, and I'd write this into your notes if I were you, under this part here. If you do not reject H naught. Oh, did I put that? Did I have you folks fill in the parts of the previous page about the not align?
Yeah.
Not. Okay. Is a line. Okay, good. If you do not reject H naught, in other words, your p-value is what? Small or large? Large. Then it is not aligned. Right? Your p-value is large. If you do not reject H naught, it's not aligned. So don't use a line to predict. Instead, use y bar, y equals y bar, to predict, or x equals x bar if you're trying to predict x. Right? If I'm trying to predict shoe size, I'd use the average shoe size. If I'm trying to predict what the grade would be, I use the average grade. Just a couple more things to point out here. So here, again, if the top one gets kind of positively correlated, then yeah, you can use a line for that. Here it's negative correlated, so as x becomes larger, my prediction would become smaller for what y would be. But here, when they're not correlated at all, you should just use the average. It shouldn't change from x depending on what the x is, because you don't know, there's no correlation. You just predict it to be whatever the average value is. Here's another example. Right, this is one that I made up on my Excel sheet. I put in the average in red, and then there, see how I found a linear regression? That black line is the linear regression line, and it's going slightly upwards, right? So for a small value, it would predict it to be, down pretty low. If I just take out a couple points, these two are both totally not correlated, right? then now all of a sudden it has a negative slope. And you'd pick something totally different. You'd say, oh, for 0 it might be like 6 as opposed to like 3. So you cannot use this line. It'll give you a line, but you shouldn't use it because it's worthless. It's useless. If your data is not correlated, just use the average. So hopefully I've bumped that into your heads enough times. We're going to do an example very quickly. Use alpha equals 0.05 to find the equation of the regression line scatter plot. And use that to approximate income for 40,000 cars. So 40,000 cars, is that my X or my Y?
Car, that's your X.
It's my, yep, that's my X. And see how the cars is in 10,000s? How many 10,000s is 40,000?
4.
4. So X here, we're saying X is 4. On the exam, I'm not going to be weird like that. I'm just going to say whatever number I give you, that will be your X. But your homework may have something strange like this where X is in 10,000s or whatever, so you might have to switch that over. So I wanted to give you one here so you'd be ready for that if you got it on homework. Okay. So here, this one was the very first example I did. So my p-value was 0.00084. No, sorry, 484. 484. And I rejected H naught. So it is a line. So that means I can use the line to predict. So my line, my A was, oh dear, now I don't remember. Did anybody write it down? It was under the example before problem 3.
0.396.
396. And B was
0.106.
0.106. Yep, sounds great. Perfect. And again, don't forget, my formula, if you remember what it is, it's at the very top when you do stat test, Lin-Reg t-test. Here, I'll show you. Stat test, Lin-Reg t-test. The very first thing it gives you is y equals a plus bx, so it gives you it right there. You can see it right there. So I have my y equals a plus bx. So I'm just going to substitute in this in for my a, and that in for my b. And I will get y equals a, which is 0.396, plus b, which is 0.106, yep, times x. So equation of a line should always be y equals something with x in it. Right? So just plug in the a's and the b's that you're given, and then you have your equation of a line. Now, I want to predict y when x is what? The very top of the page?
4.
4. Great. So I'm going to take this 4, and I'm going to plug that in.
Plug and chug.
Yep, plug that in for x. So now I'm going to have y equals 0.396 plus 0.106 times, what's my x?
4.
4. How are people feeling about this? Good? All right, so I'm just going to pop those in there. And we will get 0.424. So that means y is 0.820. If I round it a little bit. 820. Didn't turn out very well. 820. Good. And this is in billion dollars. We should probably label that a little bit to indicate, what it stands for. So when X is 40,000 cars should have an income of $0.82 billion. Okay. Okay, people feeling okay with this? Okay, great. So, need to do one. Here's the thing. Oops. You have not done the test for this one yet, I don't believe. Is that correct? So, you do have you do know what your p-value is, and your R, and your A, and your B. You have those already from lab problem 3, I believe, but you haven't done the full hypothesis test. So go ahead and do the full hypothesis test. Again, step 3 you already did, just plug those values in from step 3, and then predict, use that, and then find the equation of the regression line with y equals a plus bx, and then use that to approximate the grade for 17 abscences. 17 abscences, is that my x or my y?
X.
It's my x, so we're going to put in 17 for x, and we're going to find the y. All right, so go ahead and do your hypothesis test, and predict the grade for 17 abscences. Make sure we're all on the same page here. Okay, so step 1, h naught. You have rho is equal to 0. H1, you have rho is not equal to 0. And then step 2, you've got your alpha, 0.05. Step 3, you did Lin regression t-test, which you already did long ago, L1, L2, 1, and not equal to. You ended up with a p-value of, remember, what was your p-value again?
0.0014.
00014? 0014?
Yeah, no.
And then an R of negative 0.944?
Yeah.
And then I feel like your A may have been 102.5. And your B might have been negative 3.62?
Yes.
Great. And then what was your X bar and your Y bar?
Y bar is 102.5.
Wait, Y bar is what?
Y bar is 73.
73?
X bar is 8.143.
8.14. Okay. Good. All right, so then in step 4, is that where everybody's at right now, step 4? Okay, go ahead and finish up your step 4 and your step 5. And then again, when you're done with that, we'll approximate for 17 abscences. Okay, so step 4, you all compared your p-value to alpha. Definitely less than alpha, so you're going to reject h naught, which means is a line or not a line? Is a line. It's a line, which means that in step 5, there's enough evidence.
Well, the relation,
Yep. I'm just going to say this absences and grades,
right? Are related.
yep, are correlated. Correlated. Okay, great. So now, we need to approximate the grade for 17 absences. Is it a line?
Yes.
Yes, because I rejected h naught. So I can use the line. What is the equation for the line?
A plus bx.
Y equals a plus bx. So I want to find your line, the equation of the line, and use it to approximate the grade for 17 absences. Give you folks a couple minutes for that.
Got it.
So you're going to use your a and your b, and you're going to use your formula y equals a plus bx.
Yeah, that's fine.
I would, I think it's helpful to write is a line for step 4 or not a line. You don't have to, but I find it super helpful.
And then for number, it is.
I feel like people are done.
Says that we have to use the y equals the y bar. Or equals the x bar.
So we're using,
40.9?
again,
Yeah.
this is y equals a plus bx. So we have our a is 102.5, our b is negative 3.62. So we have y equals 102.5. Arg.
That's fine. I think that.
This is super annoying, that one. Plus negative 3.62 times x. When you add a negative, we can just, it's the same thing as just subtracting it. So I could just take out that negative there. I'll leave it there for people's sake. But we want 17 to be our x or our y? X. So x is 17. So that goes into there. So this becomes y equals 102.5 minus 3.62 times 17. And when you put that in there, you end up getting y equals 40.9. Is that correct?
Yeah.
Yeah.
Okay, good, good. So that should be your grade. What would happen if our p-value was 0.1205? What would happen then?
You would fail to reject.
Yes, so here you would, step 4, you would fail to reject H naught.
That means there is no correlation, and we just take the x bar.
Yep,
That one's easier.
so it's not a line. So everybody find, for 17 absences, what would be your grade? What would be the grade that you would expect to get? Let's take a look. All right, so if it's not a line, can I use y equals a plus bx?
No.
No, you can't. Instead, my best guess for x would be x bar. My best guess for y would be y bar. What are we guessing at here? What am I trying to find? Am I trying to approximate x or y?
X. X.
No.
It would be
17 absences is my x.
Yes.
So x equals 17. Does everyone kind of follow?
Mm-hmm.
Yeah.
Y would equal what? 73.
Oh, okay. I see.
Oh, yeah, 'cause
That makes sense.
Is that everyone kind of following? Okay. So last thing I want us to look at is going back to problem, where was it? This one, the one you folks did. So this one, I want you to predict the wealth for age of 50 years. So if I were 50 years old, what would you predict for my wealth? So go back to lab problem 4 and sort that one out. Okay, so this one, let's see. What was our A? What was the A?
Negative 3.507.
507. And what was the B?
0.446.
446. So we've got y equals negative 3.507 plus 0.446. You can multiply that by 50. Did anybody get, was it 19.7?
Yeah.
18.7.
18.7?
18.
Wait. Let's see what we got here. Well, let's calculate it very quickly. Point 446 times 50 minus 3.507.
It's not the same thing.
Did anybody get, yeah, 18.79? Is that what people got?
793, yeah.
That is completely wrong.
We were right, we were right.
was
I was gonna say, I
19.
think he's getting it. I think he's tricking us.
We rejected, we did not reject H naught,
Oh, wait.
right?
Is that,
So since we did not reject H naught, my best predictor for Y would be what?
23.21.
Y bar.
right, yeah.
Okay? So what if folks get, what's my Y bar?
23.29.
23.29, 23.3.
Yeah.
Good? All right, makes sense? All right, great. Have a good weekend. I will see you folks on Tuesday.